So if you filled in your table in number 11, you should have something similar to what I have, but your p-values will not be exactly the same as mine. And in fact, some of your p's may be where I have an r or vice versa. So even your p's and r's don't necessarily match up exactly to mine, and that's okay. It depends on the p-value that you got. Now, number 12 says, using a 0.05 significance level, which we were, and your results from number 11, provide a list of plausible values for pi, the long-run proportion of kissing couples who lean their heads to the right. So my first plausible value is 0.56, and everything after that is plausible, 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 until I get to 0.72, and that's my last plausible value for pi. Everything else above that for me is a reject. So my list of plausible values is from 0.56 up to 0.72. And again, yours may not be exactly the same as that, and that's okay. Right? Now, this may be seem a little strange because they said provide a list, and what I did is provide an interval. But of course, we can't provide a list because there are infinitely many values between 0.56 and 0.72 that are plausible. They're not just like 0.56 and 0.57 and 0.58, but for example, 0.60329 is a plausible value. So we can't really make a list per se, but we create this thing that we call an interval, and it's in parentheses so it looks like an ordered pair, but it's not an ordered pair like from algebra class. This is an interval from 0.56 up to 0.72. So it says right underneath and above the key idea, this list of values represents an interval containing all values between two endpoints. So 0.56 and 0.72 are the endpoints, we would say. All right, so here's the big idea for this section. What we've just created is called a 95% confidence interval for pi. And the reason why it's 95% confidence is because our significance level, 0.05, was 5%. So 95% plus 5% adds up to 100%. So the 95% is called the confidence level. The 5% is called the significance level. And the confidence level, it says, is a measure of how confident we are about our estimate. And we're going to talk more about that later in Chapter 3. But for now, we can say we are 95%, this is the last sentence in the key idea box, we are 95% confident that the population proportion, so all couples, this is an estimate for the whole population who lean their heads to the right while kissing, we could say is between 0.56 and 0.72, or we could say is between 56% and 72%. Okay, number 13 says, does your 95% confidence interval from number 12 include the value of 0.5? And I know without looking that the answer is no. Okay, 0.5 is somewhere to the left of, in my case, 0.56 or whatever your left-hand endpoint is. But it does include, so the answer to 0.5 is no. But it does include 0.6, that's somewhere inside the interval. So the answer to that is yes. Explain how your answers relate to the significance test and p-value that you calculated in number 7 and number 8. So in number 7, the p-value was 0 out of 1,000. So that meant that 0.5 was not a plausible value for pi. So in other words, 0.5 is not in the interval because this is an interval of plausible values. In number 8, we got a p-value, or I did, and you may have got something a little different, of 322 out of 1,000. So that meant 0.6, which is what we were testing in number 8, was a plausible value for pi. So that means 0.6 is in the interval of plausible values. 0.5 is not in the interval of plausible values. Number 14 says, now suppose we were to use a significance level of 0.01 instead of 0.05 to decide whether or not to reject the corresponding null hypothesis for each listed value of pi. Would you expect the interval of plausible values to be wider or narrower or no change? So in fact, the interval will be wider because more values will be plausible. So you remember from section 2.3 that we said the lower the significance level, the harder it is to reject the null hypothesis. So if we make our significance level lower, we're not going to reject as many values, so we'll have more plausible values. Now we're going to see this in action. Number 15 wants us to implement the 0.01 significance level. So we're going to go back up to our table, and I'm going to make a note in a different color that now our significance level alpha is 0.01. So I'm going to be comparing my p-values to 0.01. So for example, starting at the very end of the table, for an H0 pi value of 0.76, my p-value is 0.007, which is in fact less than 0.01. So this is still a reject. My next p-value, working backwards, of 0.005 is less than 0.01. That's still a reject. But 0.024, I'll just underline it here, I don't want to make it too messy on this paper, is greater than 0.01. So in fact, 0.74 is a plausible value for the parameter when the significance level is 0.01. And for 0.73, value of pi in the null hypothesis, a p-value of 0.032 is bigger than 0.01, so 0.73 is now a plausible value for the parameter. Working my way backwards, all the rest of my p-values were all bigger than 0.05, so they're definitely bigger than 0.01. When I get to 0.55 in my null hypothesis, a p-value of 0.043 is bigger than 0.01. That means 0.55 is now plausible. When I look at 0.54 and a p-value of 0.021, that's bigger than 0.01, so now 0.54 is a plausible value. Then I went back to the applet, and I encourage you to try this yourself. I put 0.53 into the top box, and I got a p-value of 0.015, which is bigger than 0.01, so 0.53 is a plausible value. And then I put in 0.52 into the applet in the top box, and I got a p-value of 0.004, which is less than 0.01, so 0.52 was now rejected. So, figuring out my plausible values, they start with 0.53, and they go all the way up to 0.74. Every single parameter value from 0.53 up to 0.74 is plausible. So I can create my interval. Let me just double check, 0.53 up to 0.74. Okay, report the interval of plausible values, 0.53 up to 0.74. So note, this is wider than the original. So just to give you a visual on that, right, I created this number line view, and now I actually am starting this interval at 0.53 and ending it at 0.74, and you can see that that's wider. The interval in pink is wider than the interval in black. It covers more values. It's got a bigger space in between the two endpoints. Now, number 16 says, how confident are you about the interval of plausible values that you listed in number 15? So, the answer is 99% confident. And why is that? My alpha value was 0.01, which is 1%. So the confidence level that we just read about in the key idea box is 99%, because 1% plus 99% add up to 100%. So the confidence level and the significance level have to add up to 100%. Now the thing that you have to be careful of is that the confidence level is always given as a percent, but the significance level, alpha, is usually given as a decimal. So in order to figure this out, we have to convert that significance level to a percent, and then we can add the two together to get 100%. So number 17 asks, what is the primary difference between the 95% confidence interval and the 99% interval? Right? The 95% interval is narrower, or saying the same thing a different way, the 99% interval is wider, which is what we predicted in number 14. That's the way we thought it would come out, and it did. So now number 18 says, how would you expect a 90% interval to compare? So a 90% interval will be narrower than both the 95 and the 99% interval. And just to demonstrate that, I'm going to go back up to our table in number 11, and at the risk of getting too crowded, I'm going to switch to blue. And now I'm going to look for p-values that are less than 0.1, right? So my alpha level for 90% confidence is 0.1, so make sure you can tell the difference. The pink is 0.01, that's 1%. The blue is 0.1, that's 10%, to go with a 90% confidence level. And so, for example, the 0.56 here, with a 0.059 p-value, that would then be a reject, because 0.059 is less than 0.1. The 0.043 p-value would lead to a reject. The 0.021 p-value would lead to a reject, right? Anytime the p-value is less than 0.1, I'm rejecting the null hypothesis. Now, my 0.57 with a 0.103 p-value, that is bigger than 0.1, so plausible. Everything else will be plausible until I get to 0.71 with a p-value of 0.102, that's bigger than 0.1, so plausible, but 0.72 with a p-value of 0.064, that is less than 0.1, so there's a reject. Let me do one more. When my null hypothesis value is 0.73, my p-value is 0.032, which is less than 0.1. That would be a reject. So my 90% confidence interval would start at 0.57. That's my first plausible value from the left. And it would end at 0.71. That's my last plausible value on the right, with a significance level of 0.1, all the p-values after 0.102 or all the H0 values after 0.71 are all rejects. So 0.57, I'll write it up above because I'm out of space, up to 0.71 would be the 90% confidence interval, and that is narrower than the black 95% interval and the pink 99% interval.